Hey all! Today, or I guess on this video, we are going to be covering Unit 3's Review FRQ, which comes from the 2016 exam. It's number 3, and I'm only asking you to do A through D, and that's because the other part of the problem deals with content that we don't have to get tested on for this year, so we're just going to ignore it. This picture, or this FRQ has lots of pictures in it, so I guess don't let yourself get too distracted by the pictures. They are kind of helpful in understanding the data, and we will read through it and get started. So the prompt says, to determine the molar mass of an unknown metal, a student reacts iodine with an excess of the metal to form the water-soluble compound Mi2, as represented with the equation above. So it tells you that you got this equation here, M and I2, and then it gives you the equation at the top. So a student reacts, the reaction proceeds until all of the I2 is consumed. So that's really important. They're telling you that that's your limiting reactant. The Mi2 aqueous solution is quantitatively collected and heated to remove the water, and the product is dried and weighed at a constant mass. So normally you guys are used to taking a look at precipitates. In this case, if you look at the picture, you're adding water, you're dissolving the stuff that you're collecting, and then they're filtering it out and heating it up to dryness. So basically they're taking it and then drying it out and collecting the stuff in solution, not the stuff that's settled at the bottom. So that's a little bit different. We've got a data table here with a ton of information. They have the mass of your beaker. They have the mass of the beaker and the original metal, the beaker plus the iodine that all went in there, and then how much this tube weighs after heating and then after a second reheat. So in number 3A, it says, given that the metal M is in excess, calculate the moles of I2 that reacted. You need to do is you need to figure out how many moles of I2 are in there in the first place. So if we look at kind of our data that we've got, I have the mass of the beaker plus the iodine, the mass of my beaker plus the metal, and then the empty beaker. Now the empty beaker, you might think, oh, that's a good idea, I want to use that. However, we need to take care of just the iodine, and the metal is already in the beaker before we get going. So we're going to use these two pieces of data to figure out our mass of iodine. What I want to do is I'm going to take 127.570 grams. That's the beaker of the metal, the iodine, and the beaker mass itself. Those are all in there. And then we are going to subtract from it the mass of the beaker and the metal, 126.549 grams. If you take that and you punch it into your calculator, you should get 1.021 grams of I2 that went into your experiment. And they are telling you that because M is in excess, iodine is the limiting reactant, which means that all of this I2 is reacting. So what I need to do is I need to convert the grams of this into moles of this. Make sure that you read carefully what the problem is asking you to do. So if I want to convert that to moles, and you could put it as a separate piece of work, or you could just keep rolling right along with the calculation, which is what I'm going to do. I'm going to convert this to moles. Remember, it is I2, moles of I2. So if I have moles of I2, the molar mass of that is 253.8 grams, and I end up with 0.004023 moles of I2. You could write that in scientific notation, or you can leave the moles as they are written, and you should be okay. Both of them would be all right. Okay, so that is part A. Now I'm going